Hello, and welcome to Inheritance and Overriding in Python. The objectives of this video is going to be to talk about what inheritance is in relation to object-oriented programming. In doing so, we'll talk about the parent class and the child class. We'll talk about creating a parent class and a child class. We'll talk about assessing the attributes in a child class and overriding the functionality of a parent class, which is basically overriding. And then basically we're going to talk about what multiple inheritance is. Okay, so we'll give some examples as we go through here. And then in the next video, we'll kind of write a program together, or at least show you a program that I have written that kind of explains this all and puts it all together for you. So you can go off and try it yourself. All right, let's get started. What is inheritance? Generally speaking, inheritance is a mechanism of deriving new classes from existing ones. In most class-based object-oriented languages, an object created through inheritance acquires all properties and behaviors of the parent object, thus the term inheriting. Sort of like if you inherit somebody's money, a old rich uncle that you found out you just inherited millions of dollars from. Wouldn't that be nice? That's kind of what this whole idea is. You're inheriting down. The concept of inheritance allows programmers to create classes that are built upon existing classes, and this makes it possible that a class created through inheritance inherits the attributes and the methods of the parent class. The goal for all of this means that inheritance supports code reusability. As I told you before, the whole idea of object-oriented, the whole paradigm of object-oriented is reuse. That's the basis of everything. Doing things one time. Okay, writing programs one time. And so what inheritance does is allows you to write something small, keep inheriting that into larger different programs this way, or more classes, I should say. This way, many people can use that same thing and eliminate the need for reuse. I have seen this in use many times. I've seen it used in industries many times. And sometimes what people will create a class for the most basic things. And maybe we'll show you an example one in here. But that's kind of the whole idea, that the basic thing is done, and then everybody inherits it as it goes through. Forms, if you actually think about Windows forms, I was working on a project once where the programming language was completely object-oriented, and we actually created a form which had the logo of the company on it. That became its own class, its own form class. Everybody inherited that. It was in the right location and so on. And then as we kind of went further, there was a form that not only had that logo on it, but also had the buttons on it and how the buttons were supposed to be presented and so on. That became its own class. People would then inherit that into their own forms that they were working on. Does that make sense? So that's kind of the whole idea, that instead of recreating things and putting new things on there, in this case GUI information, they wanted a consistency about their forms. They did it one time and one time only, and everybody inherited that. That was kind of the whole idea of object-oriented for them. In our case, it's the same thing. You can actually have GUI-based inheritance. However, what we're talking about, again, is logic-type stuff, but it's basically the same thing. Okay? So the methods, or generally speaking, the software inherited by the subclass is considered to be reused in the subclass. So speaking of subclasses and all this kind of stuff, let's kind of look what all this means. There's some different terminology that's out there based upon what language you're using, based upon what book you're reading, and so on. People call different things differently, I'm sorry to say. So there's a parent class. It is the class being inherited from. So it's basically the class that we're going to inherit everything from, okay? This has also been called the base class, and it also can be called the superclass. Got it? So whatever you're inheriting from can be the base class or the superclass based upon what book you're reading or who you're talking to or what place you're working or whatever. The child class is the class that inherits from another class, also called a derived class or a subclass. For the most part, when I learned all of this, it was called a base class and derived class. Now we got parent classes, child classes, superclasses, subclasses. Let's don't get too confused here. Read these two things one more time. Parent class is a class being inherited from. It's also called the base class or superclass. A child class is a class that inherits from another class. That's called a derived class or subclass. So the question can be, can a class be a parent and a child? For those of you out there probably thinking the same thing in the world of databases, where a table can it be a parent and a child? The answer is the same thing in object-oriented programming. Yes, it can. And we'll talk about that a little bit later on. Okay? Creating a parent class and a child class. So any class can be a parent class. It makes no difference. Any class can be a parent class. The syntax is the same. Everything we've done is the same. So this person class, in a sense, we have this first name, last name, and we're going to have a print. We're going to have a function or a method, I should say, that's going to print the first name and the last name. That is a parent class. Any class at all can be a parent class. You got it? Nothing has to change. To inherit it in Python, every language is different. Once again, how you inherit, okay? And so but this is a really important. I'm going to stress this and take a kind of time out right now. This particular course that you're taking, we're using Python to show you how to use object-oriented programming. The goal of this course, though, is to teach you about object-oriented programming. We want you to walk out of here to have a decent knowledge of object-oriented programming. However, how one language does it is completely different than how another language does it. But you should be aware that the things that we're talking about around object-oriented classes, behaviors, attributes, inheritance, polymorphism, overloading, overriding, and so on, which some of the things we'll still have to talk about, are all the same when it comes to object-oriented. Your job then is to figure out how it's done in the language that you're actually using. I get a little bit concerned that some people are trying to build upon languages, different languages. Every language is unique. Make sure you understand that. But every language every language for the most part has variables that you need to declare. It has conditional, iterative, sequential structures. It usually has some type of data structures in regards to arrays and so on. And so with that, you need to be asking the questions once you learn a language, once you learn how to write programs, the next class you take, or so maybe you go to work somewhere and they have a different language. Instead of being afraid that you don't know that language, the answer is you do know the language. Just ask the questions. How do you do these certain things? The same thing applies when it comes to object-oriented. If the programming language that you're working with is an object-oriented programming language, this is it. How do you develop a class? How do you instantiate the class? How do you create methods within the class? How do you create properties within the class, attributes, if you will? How do you inherit? How do you do polymorphism? How do you do overriding, overloading, and so on? Does that make sense? So all this is relevant to everything. Okay, back to the video. But make sure you understand that. I want to make sure, I keep reminding you that this is a course that you should get the foundation down in regards to the concepts, not so much the actual language. Okay? All right, enough of that. Sorry. To create a class, so in this case, to create a class that inherits the functionality, in Python, it's very simple. You just put the word, you put in the parentheses, we're going to define a new class called student, and in the parenthesis, person is the class right here, is the parent class. So in this case here, student will become the subclass, and person is the parent class or the superclass or the base class, whatever you want to say, that will now be part of student. So what happened here is that student now inherited everything that was in the parent class, or the person class, I should say. Okay? And you might be saying, I guess, what does this mean to do with anything? Well, let's continue on, all right? So what this does mean is this, is that if I'm a programmer and I want to create a brand new class, and I'm basically sitting back saying, well, I want to bring in some of the things that's already been done before, I can inherit those from different classes throughout my enterprise, if you will. But then what I will do is just instantiate my class, my child class, okay? And then with that, everything that's been inherited is available to me. So in this case here, X equals student, which is my child class, okay, the student, which we just defined right there, okay, and I'm going to pass it Mike and Olson, and then I'm going to print the name. But if you notice back here, there's nothing in the student class other than the fact that we just inherited the person class. And if you look at that, that's where it's going to take in the first name and the last name and so on. Does that make sense? It's rather easy. You got to play with it a little bit though, but it's rather easy once you kind of get the hang of it. Putting this all together, so we have to go back and forth in regards to the slides there. Sorry about that. Once again, here is the person class, okay? We have a INT here, okay, and we have a, so we have our constructor, if you will, correct? That will actually be executed once we instantiate it. So even though we have student, and you notice student does not have an init in there, okay? It's going to use this one. So it'll be the one that's actually was inherited. And it's going to take in Mike and Olson. And then the print name is going to be that. But we instantiate a student. The student takes in everything from the person class. Pretty simple. Yeah, you know, the one thing that I think a lot of people have a hard time with, especially getting started with object-oriented, is why would I use this? What's the purpose of it all? If we go back a few weeks ago, one of the things I wanted you to do was understand object-oriented analysis. It all goes back to that. All these classes and how they're all built is based upon the analysis. You have to remember that, okay? We're going to play around with some stuff the remaining part of this courses so you hopefully get a decent idea how to write this stuff. But in the goal of what goes in them and so on should come from your analysis, okay, and how you actually build all this, not from just arbitrarily building a program. It should come from your analysis. What is the object? What is the behavior? What is the uniqueness of that object? What should go in it? Again, you don't want to put too much in it because it might, you know, it can be inherited now to the next object that shares the same characteristics, like a person, for instance, and an employee and a student. Every employee, every student is a person. So with that, I might have a person class that I can inherit into. That's kind of the whole idea, but it goes back to analysis. Everything goes back to analysis when it comes to object-oriented. I hope you understand what I mean by that. Overriding the functionality of a parent class. There are times that you want many of the attributes and much of the functions from the parent class. Maybe you want to do it exactly what you actually just inherited. However, there are times you may want to tweak this work. You want a majority of the class, yet the one maybe a method that's in there, it's not quite what you need, and you want to be able to use something more unique for you. So you don't want to rewrite. You don't want to rewrite everything that's been done already. Meaning, you know, you want to reuse all the things that's out there that you're going to use 100%. However, there's that one thing, and what you can do with this is simply redefine the property or function in your child class. And doing that will override that same name, has to be the exact same name from the parent class. So in this case here, this is a kind of a, let me see here. So in this case, we have our class like we had before, okay? And in this case, look, there's a little bit different. So in this case, and I might have my indentation off a little bit. You know that's going to give me an error. As you notice, in this case here, what we're doing is instead of the person, we have a print here, right? I might have a brand new, I do have it right, I'm sorry. I might have a brand new print name for my particular case because my boss came to me and said, I need you to print the names out by last name and first name. And so we want to inherit all the good work of bringing in the first name and the last name into our instant variables, yet we want to change the way it's actually printed out. And so instead of just redefining the entire person class and the student class, we inherited the person class, keep all the good stuff here, then we override the print name and change it from this way to this way. And now if I did print name, it would be Olson Mike would actually come out. Does that make sense? As long as it's the exact same name as the method that you just inherited, everything will work out perfectly. Now, this is a really simple example, and unfortunately, there are a lot of simple examples out on the internet. It's the complex ones and how you really use it in real life that makes this a little bit harder. Hopefully, in our example, a little bit in our inheritance example for this week, I give you a little bit of stuff that is not as complex as you might see out there, but not as overly simple as you see here, and you can see how it actually all applies. And I'll let you kind of play with it a little bit too. Make sense? But the simplicity of it is that everything in a sense is simple, even though it could get more complex based upon what you're trying to do here. That's all we're trying to say. And this is overriding a riding, R-I-D-D-I-N-G, R-I-D-I-N-G, I should say. And that's what this is, okay? So you would know what's in these classes. When you get in the enterprise, usually there's some well-defined classes and objects. It's called an object browser. You know exactly how it needs to work and how it works, and you'll know when to override based upon what your requirements are. All right, so here it all is again, kind of putting it all together in this case. Oh, I'm sorry. So in this case here, what's kind of interesting is the init piece, okay? So if we look at this here, we sit back and we have our definition init, first name, last name, all right? As I told you before, we could have that again in our students, but in this case here is exactly the same, first name, last name. See that there? Makes no sense to have it twice because I just inherited this, but this is doing the exact same thing this would be doing. So thus, reuse, right? Why would we write it twice? Just do it one time and bring that in. All right. But wonder if we have a situation where we sit, okay, so let's go to the next step. So how would this actually work? So in this case, if you noticed before what we did, we had first name and last name being put in there, okay? Now what we can do though is that if we want to use the functionality that's in the init, and it could be more than just 2 lines of code that I have here, again, this is an example, I can very easily define my initiation here, okay? And then call this person class initiation. In this case, you might sit back and say, okay, once again, why am I doing this? Kind of bear with me here for a second. You might sit back and say, but I can call this, which will then put my first name and last name in my instant variables for me. Beautiful thing. Once again, if I'm you, I'm asking the questions, what did I gain? Why am I even doing that? Why don't I just go ahead and just inherit and everything's fine? Well, what if I have this situation where I want to bring in the first name and last name and let my base class, superclass, deal with those first 2 things. I want them to deal with it the way it's supposed to be dealt with in that base class. I can inherit that base class, as you see right here, but I also need to bring in additional information. So in this case here, I'm bringing in gender. So my data, I'm bringing in gender. I can go ahead and deal with my person.init, first name, last name, and then go ahead and put gender, then deal with gender in my own derived class, subclass, child class, whatever you want to call this. Does that make sense? And then you can see also then what I did is I overrode, okay, I overrode the print name to add last name, first name, and self-gender. So in this case, when I run this thing, Mike Olson will come in. It's going to call this init, deal with it accordingly, put them in those instant variables, if you will, correct? Instant attributes. But it's also going to take gender and put that in there. So I can build upon it. So now here's a way I can sit back and take a basic class like person, first name, last name, inherit that in without doing reuse, without rewriting it, but then also build on it. What do you think? Make sense? Take a good look at this. Once again, play with this. You can see how this all works. Playing is the best way of figuring out if this is working or not, and hopefully that you'll actually get it. Okay? All right. There's this other thing in Python especially, but you don't hear about it much outside of Python. It's called multiple inheritance. Multiple inheritance, on the other hand, is a feature in which a class can inherit attributes and methods from more than one parent class. Okay? So what this means is one class, a child class, can inherit from 2 parents. Yeah, that'd be great, right? The critics point out that the multiple inheritance comes along with high level of complexity and ambiguity. I can't say it. Can you say it? Ambiguity. Ambiguity. I can't say it. Well, it comes with some question marks in certain situations. And big, oh my gosh, sorry. All right. So in this case here, it's been a long day. So in this case here, a lot of people don't like this. As a matter of fact, in some cases, some languages don't even support it. Java, on one hand, does not support multiple inheritance. Okay. C++ does, Java does not. Okay. The widespread prejudice that multiple inheritance is something that dangerous or bad is mostly nourished by the programming languages with poorly implemented multiple inheritance mechanisms, and above all, improper usage of it. So, like I said, Java does not utilize this. C does, C++ does, and so on. But Python has a pretty sophisticated way of approaching this. This is why Python's gotten so popular nowadays in dealing with this. So let's look at this. How does this actually work? This is a really bad example, but it kind of gives you the idea of what we're talking about. I have a person class, I have a location class. In this case here, my inits here are first name, last name. My inits and my location are self and address. Again, not a great example, but you kind of get the idea. I just have a class for location and a class for person. In this case here, I'm going to take my student class, which is going to be my child class, right? And person, comma, location. That brings those both in. And if I deal with this accordingly, whoops, sorry. If I deal with this like I did before, all I need to do is pass first name, comma, last name, comma, or instantiate student with first name, comma, last name, comma, my address, comma, city, actual values in there, and everything will work out perfectly. These two things will actually be part of my piece of it. And it all works really well. The interesting part is that Python is taking care of the inits for me individually. And so in this case, I can have two inits, and they're not overriding each other. They're actually complementing each other. Once again, you can write your own init, okay? But if you write your own init, it will overlay each of these. But you also can do what we did before, if you will, and you can write your own init, bring all those things in and more, and then call a init person, a init location, and deal with it accordingly. So if I want a init person, a init location, and somewhere I want a gender in there still, I can still do it like this, and the only difference it'd be comma location right here, okay? And then you would have location dot underscore underscore init, and you would pass that data right there. Does that make sense? Same concept. All right? The last thing that we can actually do, and we kind of talked about this in the very beginning of the video, was you can also cascade inherit. I'm not sure Cascade Inheritance is my term or an official term, but basically what I mean by that is Class A can be inherited by Class B, and Class C can be inherited by, Class C can inherit Class B. Let me say this again. Class B is the child that inherits A. Class C is the child that inherits B. By doing this, B now will have A's attributes and behaviors there, and then it would also have Class B's attributes and behaviors if we had any. I just put pass in there. This says right now it's not doing anything, but I can fill all those things up with attributes and behaviors or methods, and basically all of that would be inherited into C. That's how you see a lot of languages doing it, versus this way right here, okay? I kind of like this way. I think this is kind of a neat way of doing it, meaning multiple inheritance in a way, because those two inits can really be powerful. Okay, but this is how you see most languages dealing with it, more of a cascade type thing, and Python supports this also. Okay, so wrap all this thing up. Inheritance is all about reuse. How you inherit is very similar in most languages. You got to ask the question: how do you inherit in Java? How do you inherit in VB.net or C#.net? They're all a little different. They don't put things in parentheses. Everyone's a little bit different. No big deal. Matter of fact, in VB you use the word inherit, and you actually say what you're inheriting. In this case, you put it into the brackets, if you will. So Ask those questions when you get into those languages. How do you inherit? Inheriting is the same no matter what from a theory point of view, but how you do it is a little bit different. Wonder if you want to inherit from multiple classes. Once again, based upon the language you're using, you might not be able to. In Python, you can. Okay? So in the next video, we'll put this all together. I'll show you a multiple inheritance type of situation, and hopefully it'll help you understand inheritance a little bit better, and hopefully, and also understand multiple inheritance a little bit better, and you kind of see how this works. Once again, we're talking about a theory here. We haven't put this to good practical application use yet, but you need to understand the theory before we ever do that. All right, and we'll kind of go from there. All right, good luck.